Here at COSO America, REXA electronic actuators and drives. Looking at some linear actuators used for retrofit to main boiler feed pump steam turbines in a supercritical power plant in the U.S. These actuators are linear to mount to the camshaft lever of the steam turbine. The system is designed to completely eliminate the EHC control oil system. This actuator is rated for 10,000 pounds of force, and it puts out a rated stroke of 11 inches. The stroke speeds are around 1 second, open and close. Repeatability is 0.1% of span. We have a dial indicator on here to show you this. The technology is designed to eliminate oil maintenance and complex filtration systems that are continuous maintenance issues in power plants, and one of the #1 causes of unexpected trips and shutdowns of steam turbines. So we're showing you repeatability here on this dial indicator, which is in thousandths of an inch. Business card, maybe 12 thousandths of an inch. So what drives this hydraulic cylinder is not a conventional hydraulic system where you have continuously running motors and pumps and a servo valve or proportional valve based system. This is a motor activated system. So when the 4 to 20 milliamp input signal changes, a motor turns on. We use servo motors with very high frequency response. So when I change my signal, a motor activates. When I reach position, the motor stops and the system is not operating. The response is very high because of the motors we're using. The motors are rated for 100% duty cycle, continuous operation, so they can throttle all day long. This is what the system looks like hydraulically. There is no oil tank. All we have is a large booster motor that activates for large set point changes. So if I make a signal greater than my booster pump setting, this motor and pump activates. When I get close to target position, this motor and pump stops. Then we have a smaller motor and pump here that's used for small set point changes, very fine positioning. So if I make a small set point change, only this motor activates. If I exceed the breakpoint setting, the large motor activates. This would activate normally in a load rejection situation or a turbine trip situation. We also have a fail-safe function built into the device for loss of electrical power or a trip signal where you want to drive the valves closed. So for this function we have an accumulator system which is located down here. It's compressed nitrogen. When you lose your signal, your trip signal, or your power, solenoid valves open. Allowing the nitrogen to push the oil through the system, stroking the cylinder very rapidly. When you reapply your trip signal or your power, the motor and pump recharge the accumulator system until it is ready for another failure trip, and then the solenoids close and you're back in normal operation. So we can demonstrate that function here. I'll just have you focus on the cylinder and I will kill electrical power to the actuator. This one is a fail retract, so I will go to the fully extended position and then kill power. quickly closing your steam valves. When you reapply your signal or your power, the motor and pump automatically recharge the accumulator, and then the unit goes back into normal operation. As mentioned, there is no hydraulic filtration system that needs to be maintained on a regular basis. There is no scheduled oil maintenance for this system. It is extremely particulate tolerant. You can use off-the-shelf motor oil with NAS Class 12 rating, and it is a low-volume system. So you basically only have the volume of the hydraulic cylinder, the tubing, and then an accumulator for the emergency trip function. And no oil maintenance, no sticky servo valves. This is a flow match valve based system. It is a relatively new technology, but it is mature now, and it is being implemented in retrofit on steam turbines around the world for various governor controls to eliminate maintenance problems and headaches with unstable or dirty oil and varnish buildup in EHC systems. You can visit us at www.rexa.com. Thank you.